rain rarely causes injuries. And the reason why, this here is it's almost always a flat roof. Typically a building that's not brand new, old enough that the drains can clog up. Often in places like Texas, Alabama, Southern California. Almost always commercial buildings, although not always. This was a big box store that was converted into a church. Normally there's a hole in the roof, but the hole is usually not this big. Because what happens when a failure during the rain is you get a hole from the failure, and all the water rushes in, causes a lot of water damage, but water doesn't kill anyone, and the collapse does not progress. So often you end up with a fairly small hole. But typically one hole or one bay, one rectangular area like this is quite common. Okay, collapses during construction. A lot of the construction collapses involve wood trusses, because wood trusses are very unstable during the construction phase. It takes a lot of temporary bracing, and a lot of people don't put enough, and they end up with something like this. And when you have a collapse during construction, either construction workers fall, or something falls on construction workers. So you usually have injuries and sometimes deaths. Okay. It's a big issue in our industry, these collapses during construction. Okay. Collapses due to dead load, they happen for a variety of reasons, but the most common is old masonry buildings. And you'll see this, in the older parts of almost any city, whether you're in Boulder or in a little city in the middle of Kansas or in Chicago. You get these old masonry buildings with big, thick brick walls, and they look real sturdy, but that mortar is deteriorating, and water is sometimes getting in there, and you're having freeze-thaw cycles. And at some point, that building says, this wall is so heavy that I'm coming down, and I'm going to bring a part of the building with it. So it's really a maintenance issue more than anything, but these old buildings are potentially a big issue for if you're running a building department and you have a lot of these in your area. You've got to think about that. It's interesting, in the background is another old building, but it looks really clean, well maintained. I bet somebody's doing, fixing the mortar joints in that building real well. So one of the things we see in these older buildings is there's actually an intersection, is old combined with vacant seems to result in a disproportionate number of failures. So as soon as a building is vacant, when there's a roof leak or if a wall starts to crack or a beam starts to make some noise, there's no tenant to say, hey, come and fix this. And that happens a lot. And it's interesting, some of these vacant buildings end up being owned by the city or the municipality, and they just let it sit for a couple years until it falls down. So it's a really public policy issue that when we have a building that's old and vacant, we need to do what we do in Las Vegas. We blow them up. We don't let any buildings get old in Las Vegas. Okay. In fact, we don't even let them get to middle age. Okay. Some collapses due to dead load are actually ceiling collapses, because ceilings have dead load and no live load. So they have their maximum load on the first day they're built. And sometimes they're just held up by wires and fairly weak connections, and sometimes they fall. This was in a Best Buy, ceiling collapses, and sometimes this results in injuries. It happens fairly suddenly. But there are some exceptional cases where we have roof collapses due to dead load for no reason at all. And this is an example. This is a firehouse in Utah, middle of September. Wasn't a windy day. The only load was sunlight, and it just collapsed. Okay? And this happens occasionally. These are ones you always try to say, well, why the hell did that happen? And it's amazing how people can cover up the cause. In this case, I've contacted the public officials, tried to get why did this building fail? It had wood trusses. I would guess it was a bracing issue with wood trusses, but I don't know because I can't get a hold of the forensic reports. Okay, so a few more observations. Some building types appear to have a higher frequency of collapses than others. Frequency is kind of hard to measure. In fact, it's more of a gut feel for anything. You look for buildings that have a lot of failures, and maybe, you know, in real life there's not too many of these. This is a good example. Fabric-covered buildings are not very common, but yet they seem to have a fair number of collapses in the country. How many people are football fans here? What happened last season?
Viking Stadium.
Right, Viking Stadium collapsed. It was one of these fabric-covered structures. I can cite many examples. And what's one of the biggest fabric-covered structures in the Denver area? The airport. I have to say the one thing good about the airport is the fabric is very steep. Okay, I see a lot of these fabric-covered structures, and they have a portion, like in this little building here, they have a portion here that's almost flat at the top and doesn't shed the snow well. This particular manufacturer, Coverall, is a company out of Saskatchewan. They're bankrupt now. They also did the, another thing for your football fans, the Dallas Cowboys practice facility. Remember a couple of years that collapsed and actually you know, injured some people pretty seriously. It was built by these same buildings. This company had about 5 collapses, and then they just went bankrupt. Okay. Barns and agricultural buildings seem to have a higher frequency of collapses. This is not surprising to engineers because we know that these buildings are built to lower standards. They're basically low-cost buildings. They do not have to meet the same standards as a building that's built to real commercial standards. They also have no plan submittal, no review, no building inspection, so it's not surprising that these have a higher frequency. And this is a real typical thing we see, you know, 70 cows, you know, trapped, you know, 15 saved. Now, if we were in India, this would be a very big deal. But in the U.S., we don't seem to care about too much. You know, we cut them up and eat them for steaks or something. Okay, fire stations. This is the big surprise, actually. Fire stations appear to have a higher frequency of failures. And that's really concerning because if we have some big storm or some emergency, we want the fire stations to be there. And in fact, in the building codes, they require some higher standards for fire stations. There's a rule called the importance factor that actually adds on that you have to design these buildings for a higher load, but yet, probably most of these that failed were built before that was in the code, but it's still surprising that this happened, that for some reason fire stations, and I don't know why, have a high frequency. This particular case, notice the fire station burning, the roof collapsed during a snowstorm, and it was a heavy snow in that area of the country, and several buildings failed, but you think the fire station won. And the fire station fell, broke a gas line, pulled out an electrical panel, started a fire. So not only did the fire equipment from that station get put out of service, but many other neighboring stations had to put out the fire at that fire station. So it tied up, you know, emergency facilities from a significant area of the country. And if you happen to be in a house in your garage or something caught on fire, you were probably out of luck that day. Okay. Another issue with fire stations, they are often big spans. And that's one of the correlations. Big open buildings with large spans fail at a higher rate. And that might explain why fire stations collapse, because they have a big area for these long fire trucks. And it's almost always the portion of the building that has the fire trucks. Here's one, you can see the wood trusses failed here. Looks like it was a top cord failure, but it may have been precipitated by unbraced weather. Okay. Another observation, schools. Schools seem to have a higher frequency of failure, and this is really upsetting because the community seems to get upset when schools have problems. Even when a building unassociated with directly with the school, like a school bus garage collapses, which is not uncommon. They're usually big open spans and often wood buildings. When they collapse, everybody in the community gets very upset, you know, and it gets on the media, and the school board has to explain what had happened. This one here is a steel structure over a gymnasium in Blacksburg, Virginia. And Blacksburg, Virginia is very close to Virginia Tech, which is one of the leading schools for structural engineering in the United States. This was probably the best investigated a failure that happened in the year. We know specifically what caused it. It was a steel buckling failure at a support. Very well documented. Okay, other observations. Residential buildings seem to have a low frequency of failure. So we got some good news out of this. It's not all bad news. So really, for public policy makers, if there's a big snowstorm or something in the area, the best advice is to tell people to stay home, okay? We're going to stay home, inspect the schools, inspect the fire stations, but tell people to stay home for a couple days until we get this straightened out. The only disadvantage of residential construction is that residential constructions commonly have decks, porches, and balconies, which seem to have a lot of problems that are attached to residential construction. Here's a case. This is in Austin, Texas. This is the deck, and this deck used to be horizontal across here. You can see the connection failed here where the deck meets the building. That's quite common. Okay? And the other side of the deck is actually goes on a beam here. It's hard to see because there's a tree in the way here, hiding that beam. But there's a spiral staircase, and the deck about cantilevers out around that spiral staircase. So it fell down. A lot of people injured in this particular one in Austin. Very common though. There's probably a lot of deck failures that are built like the deck we have, where the deck's only a few inches or a few feet off the ground that never get reported. But these second-story ones, people get injured and they get reported. Okay, so in conclusion, the number of structural failures in the U.S. and Canada is 350. The actual number is likely higher. And the count is very low compared to the 100 million buildings or so in the U.S. And really that is the end of the formal presentation that I gave last week at the Structural Congress.